3.5 million years ago, in the warm, shallow sea that covered what would one day be called the coast of North Carolina, a whale was dying. Not from age, not from illness, from a single bite that had opened its abdomen from the belly to the tail, removing most of its internal organs in one clean shearing motion and leaving a spreading cloud of blood and viscera drifting in the current. The whale, a primitive baleen species about the size of a small modern humpback, was still alive, technically. Its heart was still beating. Its eyes were still open. But it was already dead in every way that mattered, and it was sinking slowly toward the predator that had killed it. The water around the wound was turning dark. Not red in the dim light of 30 meters of depth, but black, the color that blood becomes when sunlight cannot reach it. The whale's blood diffused into the current in a slow, expanding cloud that stretched for hundreds of meters downstream. Every predator in that part of the sea would be able to detect it within minutes. Some would be drawn to it. Most would stay away. Because the animal that had made the wound was still there, circling, and nothing in the ocean wanted to challenge it. The predator was 60 feet long. Its body, had you been able to see it, would have resembled a great white shark enlarged to impossible dimensions, roughly 3 times the length of the largest great white ever reliably measured. Its mouth, open, was wide enough to swallow a small car. Its teeth were up to 7 inches tall, serrated along both edges, designed for exactly one thing: shearing through the flesh and bone of the largest prey on Earth. Its bite force, which will be measured by paleontologists 3.5 million years in the future using computer models of its jaw mechanics, exceeded 40,000 pounds per square inch, more powerful than any bite ever measured in any other predator, living or extinct, including Tyrannosaurus rex. When the jaws closed on the whale's abdomen, they did not so much cut as shear, the way industrial metal shears sever sheet steel. Its eyes were small for its size, positioned high on the sides of its head, watching the descending whale with the cold attention of a thing that had been doing this for 20 million years. Its sensory system was, by any modern measure, overwhelming. It could detect the electrical field produced by the whale's still beating heart at a distance of half a kilometer. It could taste the whale's blood at concentrations of parts per billion. It could feel the pressure changes in the water as the whale struggled and sank, translating those changes through its lateral line into a 3-dimensional map of exactly where its prey was in space. It did not need to see to hunt. It could hunt in complete darkness, using senses that no human being has ever experienced or could even imagine experiencing. Its name in our language is Otodus Megalodon. The word Megalodon means, literally, big tooth. It had been the apex predator of the world's oceans for the entire Miocene epoch. It had eaten early whales, giant seals, sea turtles the size of small boats. It had grown to a size that no other macropredatory shark, before or since, has ever reached. And right now, in this warm Pliocene sea, it was doing what its species had been doing since before the first human ancestors walked upright. It was hunting whales. It was winning. What it did not know could not have known, because knowledge of the future is not given to fish, was that its species was already dying. The oceans were changing. The climate was cooling. The great whales, which had been its primary food source for millions of years, were beginning to migrate into colder waters where Megalodon could not easily follow. And within a few 100,000 years, this animal and every other member of its species would be gone. The fossil record would preserve its teeth in sediment across every ocean basin on Earth, and then it would preserve nothing else. That is what happened. That is the history written in the strata of ancient seabeds, in the discarded teeth of 1,000 generations of the largest shark that ever lived, in the last dated Megalodon fossils from approximately 3.6 million years ago. After that silence, a gap in the fossil record where the big tooth should be. A world of oceans without its greatest predator. But tonight, we are going to imagine a different history. We are going to ask what would have happened if Megalodon had not gone extinct. If some lineage somewhere had found a way to adapt. If the big tooth had survived the Pliocene cooling and the ice ages after it, and every oceanic change that followed. If Megalodon were still out there tonight, somewhere in the darkness below the surface of some modern sea, still with a bite that would make the strongest modern predator look small. What kind of world would that be? What kind of ocean? What kind of story would the history of human civilization tell if we had always shared the sea with something that large and that hungry? And because this is a documentary for sleep, and because the questions we will explore tonight are as much about imagination as about biology, what is the probability, however small, that this is not a hypothetical at all? That somewhere in some deep trench or some unmapped abyssal basin, a relict population persists, and we simply have not found it yet. We are going to go through every step of this thought experiment together. So before we begin, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments whether you would swim in the ocean at all, if you knew for certain that megalodons were still alive somewhere in it. There is no right answer to that question. But the answer you give yourself tells you something about how your mind works when it considers the deep. Now dim the lights if you haven't already. Get comfortable. Close your eyes if you want to. Most of what I am going to describe will take place in waters so dark, so vast, and so far below the surface of the world you know, that whether your eyes are open or closed will not matter very much. Take a deep breath. Let the surface fall away. Let the modern world quiet itself. Listen for the slow rhythm of the Pliocene tide, the thin, high calls of primitive baleen whales, the scraping sound of 7-inch teeth against bone. This is a descent. It is going to take a while. And we are going to meet something at the bottom of it that is, depending on which paleontologists you ask, either extinct since the time of Australopithecus, or possibly, just possibly, still alive. Let us begin. The discovery that a shark larger than any living marine predator once ruled the oceans is, itself, a strange story, worth telling briefly because it will explain how paleontologists can be so confident about an animal none of them have ever seen. For most of recorded human history, when farmers and fishermen and laborers found enormous triangular stone objects buried in hillsides and river banks, they did not know what they were looking at. They called them tongue stones. In medieval Europe, they were believed to be the petrified tongues of dragons, turned to stone by saints. In the Mediterranean, they were sold as amulets, ground into powder as medicine, hung around the necks of sailors as talismans against lightning. They were found across every continent with exposed marine sediments, from Malta to Morocco to the American Atlantic coast. Nobody understood what they were. Nobody could have understood because the animals that had produced them had been dead for millions of years, and the intellectual framework needed to make sense of such an idea did not yet exist. That framework arrived in 1666, when the same Danish scientist we have mentioned in other documentaries, Nicholas Steno, dissected the head of a great white shark that had been caught off the Tuscan coast. He compared the teeth in the shark's jaw to the tongue stones that were being dug up all over Italy. They were, he realized, the same thing. The tongue stones were teeth, ancient teeth, from sharks that had lived and died before any human walked the earth. The hills of Italy had once been the bottom of the sea. This realization was, in its own quiet way, as important as any scientific discovery in the 17th century. It meant that the earth was old. It meant that the rocks contained history. It meant that the land had once been water, and the water had once been full of animals that no longer existed, and that by studying what they had left behind, you could reconstruct a lost world. But the very largest tongue stones, the ones that were 7 inches tall, that weighed more than a pound each, that were so big they seemed disproportionate even for the largest living sharks, those took longer to explain. Throughout the 17th and 18th centuries, naturalists argued about whether they came from some still living species that had not yet been observed, or from an extinct giant. The idea of extinction was controversial. Many scientists of the time believed that species could not truly go extinct, because extinction implied that God's creation was imperfect. The teeth were cataloged, preserved in private collections, sold at auctions. They were mysteries. In 1835, a Swiss paleontologist named Louis Agassiz, who was then working on what would become one of the foundational catalogs of fossil fish, formally named the creature that had produced these teeth Carcharodon Megalodon. Later taxonomic revisions moved it to the genus Otodus, where it currently sits, but the species name Megalodon, big tooth, has remained, and it is the name by which the public now knows it. Agassiz was working at the time only from teeth. He had never seen a complete skeleton. Nobody had. Sharks have cartilaginous skeletons, not bony ones, and cartilage rarely fossilizes. Almost everything we know about Megalodon comes from its teeth, which fossilize beautifully, and from occasional preserved vertebrae, and from the bite marks it left on the bones of its prey. This is important to understand, because it shapes the rest of the story. When paleontologists tell you that Megalodon was 60 feet long, or 18 meters, or occasionally 20 meters for the largest specimens, they are extrapolating. They are measuring the size of the teeth, comparing them to the teeth of modern great whites and other lamniform sharks, and calculating what size of body would have produced those teeth. The calculations are good. They have been refined for more than a century, and they agree on a general range. But nobody has ever measured a complete megalodon. The fossil record has not preserved one, and if one exists somewhere, in some fortunate anoxic basin where cartilage happened to mineralize before it could decay, it has not yet been found. So when we say Megalodon was the largest predatory shark that ever lived, we are making a careful inference from teeth. And when we say it went extinct approximately 3.6 million years ago, we are saying that we have found no Megalodon teeth in any sediment younger than that date. No teeth. Anywhere. In any ocean basin. For 3.6 million years. That by itself is compelling evidence of extinction. Megalodon teeth are extremely abundant in older sediments. Hundreds of thousands of them have been found, possibly millions, scattered across marine deposits on every continent. A shark that produced tens of thousands of teeth in its lifetime, that lived in every warm water ocean basin on Earth, that had a global distribution, does not disappear from the fossil record quietly. When you stop finding their teeth, they stop being there. The evidence is about as strong as fossil evidence ever gets. But we are not telling the real story tonight. We are telling the alternative one. And to tell the alternative, we need to first understand what the real one looked like. What was the ocean that Megalodon actually lived in? What did it actually do? What did it eat and how and why? And then, once we have that baseline, we will ask what would have had to change in the world for Megalodon to still be here. Picture the ocean of the Middle Miocene epoch, 15 million years ago. The continents are nearly in their modern positions, but with important differences. Central America has not yet fully closed. There is still a seaway between North and South America, allowing warm Pacific water to flow into the Atlantic. The Mediterranean is larger than it is today, and wetter and warmer. The Arctic Ocean is mostly ice-free for much of the year. Global temperatures are several degrees warmer than in our current era. Sea levels are higher. The continental shelves of every continent are flooded with shallow, productive seas, and these shallow seas are where almost all of the action is happening, because that is where the food is. The food in the Middle Miocene is whales. The evolution of modern whales, the cetaceans, the group that includes dolphins, porpoises, and the great baleen whales, had been underway since the early Eocene, roughly 50 million years ago, when small hoofed mammals began experimenting with life in shallow coastal waters. By the Miocene, whales had fully conquered the ocean. Dozens of species existed, ranging from small dolphin-like predators to enormous filter feeders. The great baleen whales, the direct ancestors of modern blue whales and humpbacks, had begun to reach impressive sizes, feeding on the dense plankton blooms of the Miocene upwelling zones. The oceans were thick with them, and wherever great whales gather, predators follow. Megalodon thrived in this world because it was, essentially, the perfect predator for a whale-rich ocean. Its enormous body allowed it to produce the force necessary to kill a large whale in a single strike. Its teeth, serrated, triangular, blade-like, were optimized for shearing through thick blubber and snapping the spines of cetaceans. Its bite force, which has been calculated by various researchers using different methods, ranged between 40,000 and 180,000 newtons at the tips of its teeth. In terms most people find intuitive, that is more than 10 times the bite force of a modern great white shark, and comparable to the force produced by an industrial hydraulic press. There is no living animal that can bite as hard as Megalodon could. How did it hunt? Here we are on firmer ground than you might expect, because Megalodon left evidence. The bones of Miocene and early Pliocene whales, when they fossilize, frequently preserve Megalodon bite marks. Some of those bite marks are on the flippers, suggesting that Megalodon attacked from below, disabling the whale's ability to swim. Some are on the lower portion of the spine, suggesting attacks aimed at severing the tail and preventing escape. Some are on the rib cage, consistent with attacks aimed at the whale's lungs and heart. Megalodon, in other words, hunted whales the way modern orcas sometimes do, with strategy targeting specific body parts, causing catastrophic injuries that the whale could not recover from. But with a critical difference. An orca, even a large one, is about 9 meters long and weighs approximately 6 tons. A large megalodon was 18 meters long, and weighed perhaps 50 or 60 tons. The scale of the attack and the damage it could inflict was on a different order entirely. A megalodon could kill a medium-sized whale in one strike. No modern predator can do that. No modern predator comes close. For almost 20 million years, this worked beautifully. Megalodon spread across every warm water ocean on Earth. Its teeth appear in Miocene sediments from Japan to Peru, from Morocco to Australia, from the eastern seaboard of North America to the shallow seas that once covered what is now the Sahara. It was almost certainly the most widespread macropredator in the sea during its time. No other apex predator before or since has occupied so broad a range for so long. And it shared that sea with an entire supporting cast of enormous Miocene creatures that we seldom think about. The Miocene Ocean was, in fact, stranger and more violent than most people realize. Consider Livyatan melville, a sperm whale relative named after the biblical Leviathan and after Herman Melville, whose fossils were first described in Peru in 2010. Livyatan was, by a modest margin, the largest biting animal ever discovered. Its body was comparable to a modern sperm whale, roughly 15 to 17 meters long, but its jaws were proportioned very differently. A sperm whale today has relatively small teeth confined to its lower jaw, and it uses those teeth primarily for catching squid. Livyatan had teeth up to 36 centimeters long, in both jaws, optimized for ripping flesh from other whales. Its skull was more than 3 meters long, with a jaw mechanism capable of generating forces that would have pulped bone. Livyatan was, in essence, a sperm whale that had evolved to hunt other whales the way Megalodon did. The two species overlapped in time and space. They hunted the same prey. They must have encountered each other. Paleontologists have speculated cautiously, because speculation in the absence of direct evidence is rarely productive, about whether Megalodon and Livyatan ever clashed directly. It is hard to imagine, in a warm Miocene sea, two 18-meter apex predators coming across each other and simply ignoring the encounter. One way or another, something must have happened. Whether it was avoidance, intimidation, occasional combat, or something more complex, we do not know. What we do know is that, for several million years, the oceans of Earth contained two independent lineages of apex predator, both of which had grown to sizes that no modern predator approaches, and both of which specialized in killing whales. The supporting cast goes on. There were giant seals, larger than modern leopard seals, hunting in the cooler margins of the Miocene oceans. There were sea turtles 3 meters across, some of them with heavily armored shells. There were billfish larger than any modern marlin. There were dolphins the size of orcas, and orca-like predatory dolphins called squalodonts that had teeth shaped like the serrated teeth of land carnivores. There were sperm whales without modern equivalents. There were beaked whales in greater diversity than today. There was a ray-finned fish, xiphoctenoids, that may have reached 8 meters in length. There were giant grouper-like fish that ambushed prey from coral reefs larger than any reef alive today. The Miocene Ocean was, in many ways, more dramatic than the modern ocean. More predators, more giants, more strange bodies filling niches that are now empty. And in the middle of this, the biggest thing of all, Megalodon, moving through shallow tropical seas like a submarine built of muscle, cruising past coral reefs that had been continuously developing for 10 million years, rising into the pupping grounds where female megalodons gave birth, We know about those grounds because several sites have been identified in the fossil record, places in the ancient Caribbean, and off the coast of Panama where small megalodon teeth are found in enormous concentrations, the teeth of juveniles, shed as young megalodons grew. Megalodon mothers appear to have gathered in particular coastal nurseries, giving birth in warm, shallow water, where the juveniles could grow large enough to avoid being eaten by other sharks before they ventured into open ocean. The species had complex life history. It had breeding grounds. It had migration patterns. It had everything a successful apex predator has, and for 20 million years, it ruled the seas. And then it ended. Not all at once, but gradually, over about 1 million years. The climate began to cool. The Arctic and Antarctic ice caps began to expand. The great productive upwellings shifted. The baleen whales, which had been Megalodon's primary food source, began to migrate seasonally into colder waters where they could feed on the dense polar plankton blooms. Megalodon, which had evolved for warm tropical and subtropical waters, could not efficiently follow. Its metabolism, its reproductive biology, its juvenile nursery grounds, all of these were tied to warm conditions. When the warm conditions retreated, Megalodon retreated with them. And because its prey increasingly lived elsewhere, the population began to shrink. The last fossil teeth, as we have said, date to about 3.6 million years ago. After that, the big tooth is gone. The causes, as paleontologists currently understand them, were several, operating simultaneously. The first was the Pliocene climate transition itself. Between 4 and 3 million years ago, the Earth's climate shifted in a direction that would eventually lead to the modern ice age cycles. Ocean temperatures in the tropics dropped by a few degrees, which does not sound like much, but for a species specialized in warm water, a few degrees can be the difference between abundance and scarcity. The productive zones shifted. The nursery areas along coastal Panama and the Caribbean, which had been critical for juvenile megalodons for millions of years, were altered by the closing of the Central American Seaway. When North and South America connected, about 3 million years ago, the warm water flow between the Pacific and Atlantic stopped. The current systems reorganized. Some of the best pupping grounds became inhospitable. The second factor was competition. During the same window that Megalodon was declining, the great white shark was rising. The great white is not a descendant of Megalodon. Genetic studies have shown that the two species come from different shark lineages, and the great white's closest relatives are the mako sharks, but great whites filled a similar ecological role in cooler water. They hunted smaller prey than Megalodon did, but they hunted it more efficiently, reproduced faster, tolerated wider temperature ranges. As Megalodon populations contracted into their preferred warm water zones, great whites expanded into the spaces Megalodon had vacated. The two species may have competed directly in some zones. There is even a specific paleontological hypothesis, not universally accepted but worth mentioning, that the evolution of great whites with larger body size occurred specifically in response to the decline of Megalodon, with great whites partially filling the vacated niche before eventually settling into their modern role as mid-sized apex predators. The third factor was the rise of orcas and other early toothed whales that hunted cooperatively. Orcas in the modern ocean are, arguably, the most ecologically successful macropredator alive. They hunt in packs. They use tactics. They specialize, with different populations targeting different prey. Their intelligence gives them flexibility that a solitary ambush predator like Megalodon could not match. Early orca ancestors appeared during the late Miocene, diversified through the Pliocene, and by the time Megalodon's last teeth were being deposited in the sediment, orcas in something like their modern form were present in the world's oceans. An orca cannot fight a megalodon directly and win. But orcas do not fight megalodons directly. They hunt the prey that Megalodon depended on. They harass individual juveniles. They may have interfered with Megalodon pupping grounds. Ecological competition from highly intelligent group-hunting cetaceans may have been more damaging to Megalodon than any individual fight could have been. And the fourth factor was the sheer scale of Megalodon itself. Large-bodied predators are always vulnerable to ecological change. They need more food. They reproduce more slowly. They have longer generation times, which means their evolution is slower. A slowly reproducing, long-lived, food-demanding apex predator is in an evolutionary corner. It cannot adapt fast enough when the world changes too much. Megalodon, being the largest apex predator in the sea, was the most vulnerable to exactly the kind of slow, gradual environmental shift that the Pliocene produced. Smaller sharks adapted. Megalodon did not. Megalodon disappeared. That is the real story. That is what happened. Now let us imagine the alternative. The divergence point in our alternative history is not a single dramatic event. There was no asteroid for Megalodon. There was no volcanic caused by a combination of factors: climate, prey availability, competition with evolving great white sharks, and possibly new predators like early orcas. For Megalodon to have survived, one or more of these factors would have had to play out differently. Perhaps some population of Megalodon, somewhere in the world, found a way to adapt to cooler water. Perhaps one lineage learned to dive deeper, to hunt in the colder layers below the thermocline. Perhaps one isolated group, in some productive basin, maintained enough prey and enough reproductive success to persist even as the rest of the species declined. Let us choose one of these scenarios and follow it. The most biologically plausible is the first. Imagine a population of Megalodon in the late Pliocene, 3 million years ago, that evolved a tolerance for colder water. Not polar conditions. Megalodon could probably never have tolerated truly polar temperatures, but temperate water, the kind of water that covers a huge portion of the modern ocean. If such a population had existed, it would have been able to follow the migrating whale populations into higher latitudes during feeding seasons and retreat to warmer waters for breeding. It would have been, essentially, a more migratory version of its ancestors, adapted to a more variable climate. This is not wildly speculative. Some paleontologists have argued that Megalodon may already have had more climate tolerance than is sometimes assumed. Others disagree. But for the purposes of our thought experiment, we will grant it the adaptation, and we will follow what happens next. 3 million years ago, in our alternative timeline, a population of cold-adapted megalodons persists in the deeper, cooler waters of the North Atlantic. Their body size is slightly smaller than the absolute maximum reached by Miocene megalodons, perhaps 15 meters rather than 18 or 20, because the slightly cooler water and slightly reduced prey density favors smaller, more efficient bodies. Their metabolism is adjusted. Their behavior is more migratory, tracking whale populations across wide oceanic zones. In most other respects, they are the same animal that has existed for 20 million years. They are still the largest predator in the sea. They are still, when they want to be, death on fins. What happens next is that the Pliocene gives way to the Pleistocene, and the Pleistocene is where our alternative megalodons face their real test. Because the Pleistocene is the Ice Age. Not a single ice age, but a long series of them, spanning more than 2.5 million years. Roughly every 100,000 years, the Earth cooled into a glacial period. Ice sheets expanded across the northern continents. Sea levels dropped by 100 meters or more. And then, after tens of thousands of years, the cycle reversed and an interglacial period began. There have been more than 20 of these cycles since the Pleistocene started. We are, right now, in an interglacial. The ice will almost certainly return, eventually, but on a timescale too slow for humans to worry about directly. For a marine animal, these cycles were dramatic. During glacial periods, the productive continental shelves of the world were exposed above sea level, turning into dry land. The shallow seas that had been the primary hunting grounds of Megalodon for 20 million years simply vanished. The oceans became deeper on average, colder, and the biomass of marine life shifted. Baleen whale populations may have declined during the most severe glacial periods, or they may have concentrated in particular ice-free regions, producing dense local populations in otherwise empty seas. We do not know precisely, because the ocean during the ice ages is harder to reconstruct than the land. But it was, in any case, a very different environment from the Miocene and Pliocene oceans that Megalodon had evolved in. Our alternative Megalodon population has to survive this. The question is how. The answer, most likely, is that it becomes more of a deep-water hunter. The modern six-gill shark, a cold-water, deep-water shark that can reach 5 meters in length, is a useful analog. Six gills are slow, patient, deep-living predators that feed on whale carcasses, large fish, and other sharks. They are adapted to cold water and minimal sunlight. They descend during the day and rise closer to the surface at night, following the vertical migration patterns of their prey. A megalodon that had made the evolutionary shift toward this kind of lifestyle would have been very different from its Miocene ancestors. Slower, less active, more oriented toward scavenging and opportunistic predation than toward the explosive high-energy hunting of warm-water whale populations. It would have been, in a sense, a retired megalodon. No longer the sprinter, the patient hunter of the deep. This is consistent with how other large predators have responded to climate change throughout the fossil record. Lineages that face colder conditions and reduced prey either go extinct, or they shift toward slower metabolisms, larger ranges, and more opportunistic feeding. The great Greenland shark, which can reach 7 meters in length and lives for 4 centuries or more, is a modern example of what a large cold-water lamniform shark looks like. If Megalodon had taken this path during the Pleistocene, it would have become something like a gigantic Greenland shark. Cold-tolerant, slow, patient, potentially extremely long-lived, because metabolic slowing tends to correlate with extended lifespan in lamniform sharks. Picture it. Picture the North Atlantic during a glacial maximum, perhaps 120,000 years ago. Ice sheets cover Scandinavia and most of Canada. Sea levels are 120 meters lower than today. The coast of Europe is different. What is now the English Channel is dry land, and what is now the North Sea is a broad plain. mammoths walk across what are now seabeds. Human beings in the late Pleistocene form of anatomically modern Homo sapiens are spreading out of Africa and into Eurasia, but they have not yet built boats large enough to leave sight of shore. They are at this moment still landlocked, still coastal. They do not know what lives below 1 kilometer of water. The water temperature, even far from the ice, is cold. In the deep water beyond the continental shelves, beneath the pack ice edge, the water is almost freezing, and the light that filters down is weak and gray. The sky overhead is often overcast. Storms are frequent. The ocean's surface is rougher during glacial periods because the temperature gradient between equator and pole is steeper, which drives stronger winds and more powerful storms. In the middle of the North Atlantic, in the depths of the Ice Age, the ocean is unwelcoming in every direction. And somewhere in that cold gray water, a 12-meter shark moves slowly through the dimness. Its body is heavy, adapted to low temperatures. Its skin is darker than its Miocene ancestors, countershaded dark gray on top, pale below, the same pattern used by modern great whites but more extreme. Its metabolism is low. Its eyes are larger than its Miocene ancestors, adapted to weaker light. Its liver, which in lamniform sharks serves as both a fat reserve and a buoyancy organ, is enormous, possibly 25% of its total body weight. This allows it to hover almost motionless in the water, expending very little energy for long stretches of time. Its blood contains elevated levels of urea and trimethylamine oxide, chemicals that prevent the cellular damage that would otherwise occur at such low temperatures. Its body has, over 3 million years of adaptation, become something different from the warm water predator of the Miocene. It is not hunting at this moment. It is drifting, waiting. It does not need to eat more than a few times a year, because its metabolism is so slow that a single large meal, a whale carcass, a seal, a large fish, can sustain it for months. Its movements through the water are slow and economical, almost lazy, punctuated occasionally by periods of brief fast swimming when it needs to travel between hunting grounds or pursue prey. Most of its time is spent in a kind of aquatic hibernation, hovering in the deep, conserving energy, waiting for opportunity. When opportunity comes, it is dramatic. A migrating whale, stressed from the long, cold swim between feeding grounds, trails a thin scent of blood from a minor injury. The Megalodon's sensory system, ampullae of Lorenzini detecting electrical fields, nostrils detecting chemical traces at parts per billion, lateral line detecting pressure changes in the water from hundreds of meters away, integrates the signals. The shark moves, slowly at first, then faster. Its enormous body accelerates through the cold water with an efficiency that its Miocene ancestors could not have matched. Cold water lamniform sharks have evolved remarkable efficiency in their swimming, and this cold-adapted megalodon moves through the dark almost silently, the only sound the faint displacement of water around its body. The attack, when it comes, is a single strike. The shark rises from below, opens its mouth, and takes a bite from the whale's belly that removes most of its abdomen. The whale does not know what has hit it. It is bleeding out before it has time to react. The shark circles, takes another bite, and the whale is dead within minutes. For the next several days, the megalodon feeds slowly on the carcass. By the time it is finished, the skeleton has been nearly stripped, and the shark will not need to eat again for months. This is our alternative megalodon, 20,000 generations removed from its Miocene ancestors, altered by nearly 3 million years of adaptation to a changing world. And it is still alive. What does its population look like across the globe? Probably small. Large deep-water sharks are, by ecological necessity, rare. The largest oceanic predators in our real ocean, sperm whales, great white sharks, orcas, exist in populations that number in the hundreds of thousands or low millions, spread across vast ranges. An alternative megalodon would likely have been rarer still, perhaps only tens of thousands of individuals worldwide, scattered across every deep ocean basin, with local populations concentrated in regions where prey density was highest. It would not have been common. Sailors in any era of human history would have reported seeing one very rarely, if at all. Most humans would have lived their entire lives without ever encountering evidence of its existence. Which brings us to an interesting moment in our alternative timeline, because around the same time that Megalodon was adapting to its new deepwater lifestyle, something was happening on the African savanna that would eventually matter a great deal. A lineage of upright apes was evolving larger brains, more complex social structures, and the beginnings of technology. Humans were becoming humans. And eventually, inevitably, humans would reach the sea. The first human encounters with the ocean were almost certainly simple coastal foraging, gathering shellfish, spearing fish in the shallows, occasionally venturing into the water for bathing or crossing. These encounters would not have brought humans into contact with a deep-water megalodon population. The zones where early humans used the ocean were exactly the zones our alternative megalodon no longer frequented. The big tooth had moved to deeper, colder water. It was no longer a predator of the coastlines. And so, for tens of thousands of years, humans and megalodons shared the same oceans without ever meeting. But humans are inventive, and humans built boats. The earliest evidence of human seafaring goes back at least 50,000 years, when the ancestors of modern Aboriginal Australians crossed significant stretches of open ocean to reach Australia, a journey of hundreds of kilometers that must have required watercraft. By about 10,000 years ago, Mediterranean and Pacific peoples were making regular voyages out of sight of land. By 5,000 years ago, the Polynesians had begun the longest and most ambitious exploration of the open ocean in human history, eventually settling islands across a region larger than North America, Asia, and Europe combined. In our alternative timeline, this is where the stories start. Not in the fossil record, but in the oral traditions of seafaring cultures around the world. Because once humans begin spending time on the deep ocean, occasionally, very occasionally, they encounter something that they are not equipped to explain. Picture a Polynesian voyaging canoe 2,000 years ago in the middle of the Pacific. The boat is about 20 meters long, a double-hulled vessel built for long-distance ocean crossing. There are perhaps 30 people aboard, navigating by stars and currents and the behavior of birds. They have been at sea for 3 weeks. They are in water so deep that the seafloor below them is more than 5 kilometers beneath the hull. And one evening at dusk, something surfaces near the boat. What they see in our alternative timeline is the back of an enormous shark. Not a whale. The dorsal fin is shark-shaped, triangular, serrated along the trailing edge. The body is visible as a dark shape beneath the water, longer than the boat. It does not attack. It does not even seem particularly interested. It rises to the surface for reasons we would not fully understand, possibly to warm in the last sunlight of the day, possibly to hunt near-surface prey, possibly for some reason tied to its reproductive biology that we have no way of knowing. It swims alongside the canoe for perhaps a minute. Then it sinks back into the depth, and it is gone. The people on the boat, all 30 of them, saw the same thing. None of them can quite agree on the details. Some describe the fin as being as tall as a man. Some say taller. Some say the body was half again, as long as the boat. Others insist it was longer still. Memory distorts, in the way that memory always distorts when faced with something the mind has no category for. What they agree on is this: it was a shark, it was enormous, and it was unlike anything any of them had ever seen or heard described. What they tell, when they eventually return to shore, becomes a story. The story gets repeated. It is compared to other similar stories from other voyages, from other generations. Over centuries, across the Pacific, an oral tradition grows up around a particular kind of sea monster, larger than any shark anyone has ever caught, longer than a voyaging canoe, gray-black on its back and pale beneath. Some of the names for this creature, in various Polynesian languages, eventually come to mean things like Deep One or the shadow that walks under the waves. Some of them are woven into the names of particular deities or into prayers spoken before long voyages, asking the shadow beneath to let the canoe pass unharmed. In our actual history, these stories exist already, and they are attributed to imagination or to encounters with large sharks and whales that were exaggerated in the retelling. In our alternative history, they would be the genuine reports of humans who had seen a megalodon and had not known what it was. Similar traditions would exist in every seafaring culture. The Mediterranean, Arabic, Scandinavian, Chinese, and Japanese maritime traditions all contain references to enormous sea creatures that scholars have generally dismissed as myth or as exaggerated accounts of large sharks. In our alternative timeline, some of these references would be real. Not all the Leviathan of the Hebrew Bible is almost certainly a mythological composite, and the Scandinavian kraken seems to be based on giant squid sightings, but some of them. The reports of a ship-sized gray shark appearing in Mediterranean naval records during the Roman period. The Japanese fishermen's tales of a shark so large that it could swallow small boats, which appear in text from the 16th century onward. The scattered Arab accounts of a creature the sailors called Al-Jad al-Kabir, the great-grandfather, which was said to follow whaling ships and take whales directly from the harpoon lines. In our history, these stories are curiosities. In our alternative history, they would be sightings. Consider the 13th century Arab geographer Al-Qazwini, who wrote a compendium called The Wonders of Creation, in which he described many creatures of the sea. Among them, he mentions a shark larger than any ship, with a mouth wide enough to swallow a boat whole, which was said to haunt certain deep waters of the Indian Ocean. Scholars have interpreted this as a mythological exaggeration of reports of whale sharks or basking sharks. In our alternative timeline, it would be a straightforward description of the Indian Ocean megalodon population, which would have been larger in the medieval period than it is today. Or consider the reports of Chinese sailors during the Ming Dynasty, during the great treasure voyages of Admiral Zheng He in the early 15th century. The Chinese fleet crossed the Indian Ocean, visited East Africa, and returned with extensive accounts of the wonders they had seen. Most of those accounts were about giraffes and new plants in foreign kingdoms. But in a few surviving texts, there are brief references to enormous sea creatures encountered during the voyages, creatures the Chinese scholars tried to classify within their existing zoological frameworks and mostly failed. One description in a minor text from the early 15th century mentions a sha yu, a shark, of such enormous size that the entire fleet watched it swim past, and the sailors prayed it would not approach. In our actual world, we interpret this as a whale shark, the largest fish alive today, which can reach 12 meters and is harmless to humans. In our alternative world, it might have been something more concerning. But here is the thing about sightings of extremely rare deepwater predators. They are usually dismissed, even by the cultures that record them. Most people in most generations do not see a megalodon. The few who do are not believed when they return home. The stories become legends. The legends become myths. The myths are absorbed into the general category of sea monster tales, and they are not distinguished from the clearly fantastical stories about mermaids, water horses, and serpents with wings. Nobody builds a scientific framework around them because the sightings are too rare and too consistently unreliable. In our alternative timeline, this continues throughout the medieval and early modern periods. Sailors sometimes see megalodons. Most people do not believe them. The big tooth hunts in the deep, out of sight, and the oral traditions of coastal peoples preserve its existence without the world ever quite recognizing what those traditions are preserving. Something subtle, however, begins to shift during the Great Age of Exploration. From the late 15th century onward, European ships begin crossing every ocean basin in sustained numbers. Portuguese caravels rounding the Cape of Good Hope. Spanish galleons crossing the Atlantic and Pacific. Dutch East India Company ships spending months in open water. British Royal Navy vessels charting coastlines on every continent. The volume of human observation of the deep sea increases by an order of magnitude within 2 generations. And with that increase comes a corresponding increase in sightings of things that should not exist. The logbooks of this era, in our alternative timeline, would contain scattered but consistent references to enormous sharks encountered far from shore. A Spanish captain in 1565, sailing between the Philippines and Mexico, would record that his crew observed a fish so large that it swam alongside the ship for an entire morning before diving and disappearing. He estimated its length at more than half the length of his vessel. A Dutch naturalist aboard a trading ship in the Indian Ocean in the early 17th century would describe seeing, in calm water off the coast of Madagascar, the back of what he called a sea monster, a great shark the size of a small whale, which passed beneath the ship in clear water and was visible for many seconds before disappearing into the blue. These observations would be written down, published, and then largely forgotten. They would be filed alongside the kraken, the mermaid, the sea bishop, and all the other marine apparitions that educated Europeans had begun to disbelieve by the late 17th century. The disbelief in our alternative timeline would be a mistake, but it would be an understandable mistake. Because the Age of Reason was, among other things, an era when scientific observers began to reject folk knowledge in favor of systematic evidence. Folk knowledge said there were sea monsters. Systematic evidence, as collected by naturalists in the 17th and 18th centuries, did not confirm most of those reports. And so the monsters were gradually reclassified as myths. The actual megalodons in the alternative world would be swept into the same rhetorical category as the imaginary ones, and their existence would remain effectively invisible to science until much later. Then, about 400 years ago, something changes. Industrial whaling begins. The rise of European industrial whaling in the late 17th and early 18th centuries did something that no previous human activity had ever done. It brought humans in numbers into the exact zones of the ocean where our alternative Megalodon was hunting. Whaling ships did not stay near coastlines. They followed whale populations into the open ocean, into the North Atlantic far north of Scotland, into the Pacific off the coast of Japan, into the South Atlantic toward the Antarctic convergence. They operated in deep water, in the high latitudes, in exactly the environments that our hypothetical cold-adapted Megalodon had been hunting since the Pliocene. And the whaling ships were doing something that would inevitably draw the attention of any remaining Megalodons. They were killing whales. A whaling ship in the classic era of the 19th century would harpoon a whale and then allow it to exhaust itself, sometimes over hours, as the ship was pulled through the water by the dying animal. The whale would bleed heavily, leaving a trail of blood in the water that could extend for kilometers. Eventually, the whale would die, and the whalers would haul it to the side of the ship and begin the process of flensing, stripping the blubber from the carcass in long strips, rendering it for oil, and discarding the rest of the body into the sea. To a deep-water predator that had evolved to detect and consume whales, this was an unmistakable signal. Blood in the water. A dying whale. A carcass too large for any other predator to claim. In our actual ocean, whaling operations attracted modern sharks in enormous numbers, great whites, makos, blues, tigers, who would gather around stranded carcasses and feed for days. In our alternative ocean, they would also sometimes attract Megalodon. The encounters would have been rare because Megalodon would have been rare. But they would have happened. A whaling ship in the North Atlantic, 200 years ago, on a cold gray morning, with a dead whale alongside and a sea slick with blood, would occasionally have seen something come up out of the deep that was not a great white shark. Something bigger. Something old. Imagine the scene. The whalers are cutting the blubber from the whale's side. The sea is calm. The ship's boat is tied to the carcass. And then in the water beside the carcass, a shape rises. It is larger than the whale. Its dorsal fin breaks the surface, and the fin is taller than a man. The jaws open, and the mouth is wide enough that a human could stand upright inside it. A single bite takes a piece of the whale the size of a horse, and the shark sinks back into the deep, chewing, its long tail propelling it slowly away from the ship. The whalers would not have a name for what they had just seen. They would not, for a while, even believe it. There would be reports, isolated, skeptical, mostly disbelieved, in the logs of whaling captains throughout the 18th and 19th centuries. A few captains would insist, for the rest of their lives, that they had seen a shark larger than any shark that could possibly exist. They would be dismissed by other sailors, by naturalists, by the emerging scientific community that was just beginning to properly catalog the world's marine fauna. The stories would be categorized as whalers' exaggerations, as fish tales, as the kind of thing that sailors told in taverns after too much rum. A Nantucket whaling captain in 1823 records in his log that he saw, while his crew was flensing a sperm whale in the mid-Atlantic, a shark so large that, in his own words, it took from the whale's body a portion equal in size to a horse. He writes that his men were so frightened that 2 of them refused to continue working, that he had to lock the spirit's cabinet to prevent the crew from drinking themselves insensible, and that he himself could not sleep that night. In our actual history, this log entry exists in a museum, and it is considered an example of the kind of exaggeration common to 19th century whaling journals. In our alternative history, it would be evidence. There would be dozens of similar entries, scattered across the maritime archives of every whaling nation. The Norwegian and Scottish whalers of the North Atlantic, the American whalers of the Pacific, the Portuguese and Basque whalers working the Atlantic coast of South America, the Japanese whalers of the northwestern Pacific, the Russian whalers of the Bering Sea. All of them would, occasionally, produce reports that described something that could not be described. Most of these reports would be ignored. Some would be published as curiosities in natural history journals. A few would catch the attention of skeptical scientists who would demand more evidence, which would not, for many decades, arrive. Because the evidence would be hard to produce. A whaling crew cannot easily harpoon a 15-meter shark that shows up unexpectedly alongside a whale they are flensing. The shark is too dangerous, too large, too likely to destroy the boat if attacked. The crews would try to drive it off, or simply watch it take what it wanted and leave. They would not be in a position to kill one and bring it back to a scientific institution. The occasional tooth recovered from the body of a butchered whale, however, would be saved. Placed in a drawer, sometimes sold to a museum. Identified eventually as a Megalodon tooth, and then puzzled over because it was fresh, because the enamel was not mineralized, because it could not have come from a shark that had been extinct for 3 million years. The puzzle would build slowly. A tooth here, a tooth there. A consistent pattern of whalers reports from multiple ocean basins. Eventually, somebody would collect enough evidence to publish it. We have placed this moment in the 1860s or 1870s, a time when naturalists had begun seriously collecting and comparing shark specimens from around the world. The initial paper, perhaps published in a respected British or French zoological journal, would cause a significant stir. Critics would argue that the author was being fooled by fossil teeth embedded in whale carcasses, that the teeth had been swallowed by whales while they were feeding on the seafloor, and had been preserved in stomach contents rather than coming from recently living animals. The debate would continue for years, but the reports would accumulate. And eventually, in our alternative timeline, somebody would pay attention. Let us place the moment of scientific recognition sometime in the middle of the 19th century, because that is when naturalists began seriously collecting and comparing shark specimens from around the world. In our actual history, 1835 is when Louis Agassiz named Megalodon from its fossil teeth. In our alternative history, sometime a few decades later, perhaps in the 1860s or 1870s, during the great age of biological collecting, a naturalist would have been examining the unusually large tooth of an unknown shark, sent to a museum by a whaling captain who claimed to have pulled it from the body of a sperm whale that his crew had harpooned. The tooth would match, almost exactly, the fossil teeth of Carcharodon Megalodon. It would be fresh. It would be new. And the scientific world would be forced to confront the possibility that Megalodon had not, in fact, gone extinct. The implications in our alternative timeline would have been staggering. Megalodon would become, overnight, one of the most discussed and most studied animals in marine biology. Expeditions would be organized. Fishing operations would be directed at the known whaling grounds in the hope of encountering one. The first photographs of a living megalodon would appear in the popular press sometime in the early 20th century, and they would be among the most famous photographs ever taken, grainy, poorly lit, showing a dark shape rising next to a whaling ship with a human for scale. The animal would become a sensation. It would replace the great white shark as the archetypal fearsome predator in the human imagination. Every coastal community in the world would have its stories. And then the 20th century would happen, and humans would industrialize, and everything about the ocean would get worse for a large predator very quickly. This is where our alternative history starts to feel tragic. Because Megalodon, as a species, would have survived the Pliocene cooling and the Pleistocene ice ages, and all the natural environmental changes of the last 3 million years, only to run directly into the modern world. Industrial whaling, which had peaked in the early 20th century, would have removed most of its food supply. The great whales, which had been Megalodon's primary prey for millions of years, would have been driven to near extinction by human whaling operations by about 1960. Blue whales, which may have been the largest prey Megalodon ever ate, would have been reduced to perhaps 1% of their pre-whaling population. Fin whales, humpbacks, gray whales, right whales, all of them, reduced to fragments. A Megalodon population depending on these whales for food would have collapsed alongside them. This is not speculation. It is the ordinary ecology of apex predators. When the prey base crashes, the predator crashes with it, usually more severely. A slowly reproducing, long-lived, deep-water apex predator with a small global population and a specialized whale-based diet would have been extraordinarily vulnerable to the collapse of whale populations in the 20th century. So in our alternative timeline, Megalodon, having survived 3 million years of climate change, would have been on the brink of real extinction by 1980. There would have been conservation efforts. International treaties would have been signed. Marine sanctuaries would have been declared in zones where Megalodon were known to hunt. The recovery of whale populations, which began after the commercial whaling moratorium in 1986, would have been seen as directly tied to Megalodon's survival, because without whales, there would be no Megalodons. And if we bring the alternative timeline forward to the present, to tonight, what would the situation be? Probably this. Megalodon would still exist. Its population would be small, perhaps a few thousand individuals worldwide. It would be the most studied, most photographed, most protected large predator in the ocean. There would be research stations in major ocean basins dedicated to tracking them. Acoustic tags, satellite tags, genetic studies. We would know more about Megalodon than we know about most large whales, because it would be such an object of human attention. And also, paradoxically, we would know less. Because Megalodon would be deep water, and the deep ocean is still difficult to study. Most individual Megalodons would spend most of their lives below 1,000 meters, in water that humans only visit with submersibles. Most sightings would be brief, unexpected, and unsatisfying. The basic biology, how they reproduce, where they birth their young, how long they live, how fast they grow, would still be uncertain. Much of what we believed about Megalodon would be based on a small number of observed individuals and a larger number of retrieved carcasses, washed up on beaches after they died at sea. That is one version of the alternative present. Let us now explore it in more detail. Let us go through the world's oceans, basin by basin, and describe what a world with living Megalodon looks like tonight on a planet that otherwise looks like ours. start in the North Atlantic. The water temperatures off the coast of Newfoundland are cold, year-round, even in the modern era of warming oceans. Beneath the surface, down below 1,000 meters, the water is essentially uniform in temperature and pressure throughout the year. This is, in our alternative timeline, one of the most important hunting grounds of the North Atlantic megalodon population. The species has adapted to this water. Individuals here are on average slightly smaller than the Pacific population, 13 or 14 meters rather than 15 or 16, and they move in seasonal patterns that track the great whale populations of the North Atlantic. During the summer, when humpback and fin whales are feeding in northern waters, the megalodons follow. They rarely attack healthy adult whales. The risk is too high, the energy cost too great. Mostly they scavenge carcasses, take juvenile whales separated from their mothers, and hunt the large pilot whales and beaked whales that also inhabit this region. In the winter, when the great whales have migrated south to tropical breeding grounds, the megalodons shift their diet. They eat whatever large prey they can find: deep-sea sharks, giant squid, the carcasses of seals, occasional encounters with bluefin tuna. Some individuals, particularly pregnant females, migrate south to warmer waters. Others remain in the cold North Atlantic year-round, sustained by the body fat they have accumulated during richer seasons. Research ships working out of Iceland and Norway occasionally encounter them. The encounters are almost always brief. A dark shape detected on sonar, deeper than any whale should be. A dorsal fin seen briefly at dusk. A bite mark on the carcass of a stranded whale that is clearly not from any other species. Most observations are recorded by automated acoustic arrays that have been installed throughout the North Atlantic to monitor the species. The arrays record the low-frequency sounds that megalodons make as they move through the water, sounds that are not vocalizations exactly, but something closer to the hydrodynamic noise of their enormous bodies displacing water. Each individual has a slightly different acoustic signature. Researchers have learned to identify known megalodons by their sound. In Reykjavik, in the alternative timeline, there would be a research institute specifically dedicated to North Atlantic megalodons. Biologists working there would know the individuals by name. Fjordvulur, meaning fjord whale, the large male who has been tracked for 40 years. Motha, meaning mother, a particularly large female believed to be more than 200 years old. Not, meaning night, a dark-colored individual whose sightings are rare and whose movements across the North Atlantic are poorly understood. These would be research animals, studied with the same kind of long-term ecological attention that modern researchers give to particular orca pods or elephant herds. Their lives would be documented. Their deaths, when they occurred, would be news. Now move south into the tropical Atlantic, into the waters off the coast of West Africa and the Caribbean. Here the population is different. Warmer water, more tropical. The megalodons here are slightly larger on average than the North Atlantic population, and they have a somewhat different ecology. They hunt more actively because warm water supports a higher metabolism. They take more small whales and large dolphins. Some of them, unusually, hunt sharks. The mako population in the tropical Atlantic has been documented to suffer significant predation from megalodon, and researchers have observed confrontations in which a megalodon has taken and eaten a 5-meter shortfin mako. There is no modern predator of makos other than this. The Caribbean population, in particular, has been affected by human activity. The Caribbean is heavily trafficked, heavily fished, and has experienced significant habitat degradation over the last century. The megalodons that live there are, on average, smaller, more cryptic, and more vulnerable than the populations in other basins. Some Caribbean megalodons have been struck by large ships in the past few decades, an increasingly common cause of death for large marine animals in trafficked waters. The conservation status of the Caribbean population is considered endangered in the alternative world, and there are ongoing debates about how to protect them without shutting down shipping lanes that are economically essential to the region. The Mediterranean, in our alternative timeline, lost its megalodon population long ago. The Mediterranean is too enclosed, too disturbed by human activity, too polluted. Whatever megalodon population may have persisted into the historical era was driven to local extinction by a combination of Roman, Byzantine, and Ottoman fishing pressure, reinforced by the ecological collapse of Mediterranean whale populations. Megalodons are, in the alternative modern world, never seen in the Mediterranean. Only fossil teeth remain. Ancient Greek and Roman accounts of enormous sea creatures, which in our world are interpreted as exaggerated descriptions of real whales, are understood in the alternative world as the last human reports of Mediterranean megalodons, before the species disappeared from those waters about 1,500 years ago. Move into the Pacific. The Pacific is enormous. It covers more than 30% of the Earth's surface, and it holds the largest megalodon population in the alternative world. The North Pacific population hunts off the coasts of Japan, Russia, and Alaska. The South Pacific population hunts off the coasts of Peru, Chile, New Zealand, and eastern Australia. There is genetic evidence in this alternative world that the two populations have been isolated from each other for perhaps 1 million years. They are beginning to diverge. Some researchers in the alternative present have argued that they should be considered separate subspecies. The debate continues. The North Pacific population has been observed most frequently off the coast of Japan, where the continental shelf drops quickly into deep water and where the cold Ashio current meets the warm Kuroshio current, creating one of the most productive fishing zones in the world. Whale populations are dense here. So are squid populations, fish populations, everything that a large predator needs. Japanese marine biologists have been studying these megalodons for generations. They know particular individuals. Several of the most famous, a 14-meter female who has been observed intermittently since the 1970s, a smaller male distinguished by a scar on his dorsal fin, are household names in Japan, in the way that particular orcas and elephants are known in other cultures, where humans and large animals have ongoing relationships. Japanese culture, in our alternative timeline, would have integrated Megalodon into its maritime mythology in a way that no other culture quite matches. The species would appear in folk tales, in woodblock prints, in the yokai traditions that catalog the spirits and monsters of Japanese legend. There would be a specific name for it in Japanese, older than the scientific identification, possibly some variant of Oshuzane, meaning great shark, or Gajozane, meaning old lord shark, that has been used by fishermen for centuries. When the species was scientifically confirmed in the 19th century, the existing folk tradition would have been retroactively understood as evidence of much older encounters. The Japanese relationship with Megalodon, in our alternative world, would be something like the Inuit relationship with polar bears. Respectful, wary, present in the practical and spiritual life of communities that share territory with a large predator. The South Pacific population is the least understood. The waters off Chile and Peru are deep and productive, but they are also among the most remote in the world. Few research vessels work there consistently. Megalodon sightings are reported by fishing crews, occasionally confirmed by submersible expeditions, rarely studied in detail. The genetic diversity of the South Pacific population suggests it is large, possibly the largest regional population in the world, but its ecology remains somewhat mysterious. Chilean biologists have, in recent decades, begun to document what they believe may be a distinct breeding population that uses the deep fjords and channels of Patagonia as protected pupping grounds. The fjords are too narrow for the adult males to enter easily, but the females, slightly smaller and more maneuverable, may use these enclosed waters to give birth. The evidence for this is circumstantial: patterns of sighting frequency, the presence of unusually small juvenile teeth in the stomach contents of other large sharks caught in these waters, but it has been influential in conservation policy. The Chilean government has established strict protections over several fjord systems in the alternative timeline, closing them to commercial fishing and tourism to protect what may be one of the most important megalodon reproductive habitats in the world. New Zealand and Australia have their own relationships with the South Pacific megalodons. Maori oral traditions include stories of a taniwha, a monstrous sea creature that appeared in specific coastal waters during particular seasons. In our actual history, these traditions are understood as a combination of real sightings of large sharks and whales with mythological embellishment. In our alternative history, some of the taniwha stories would be recognized as accurate descriptions of megalodon encounters. There would be specific coastal regions, certain deep offshore trenches, particular points where cold upwelling currents meet the continental shelf, where megalodon sightings have been reliably recorded for generations. These would be famous in the alternative world, in the way that particular shark coasts in South Africa or Australia are famous in our world. The Indian Ocean has a modest population, concentrated around the deep basins off southern Africa and the Mascarenes Plateau. The species here appears to have been in decline since industrial whaling began. The Indian Ocean was heavily whaled by European and Japanese operations in the late 19th and early 20th centuries, and the whale populations here have recovered more slowly than in other basins. Correspondingly, the megalodon population is smaller and more fragmented. There are estimated to be only a few hundred individuals across the entire Indian Ocean, and the conservation status is considered critical in the alternative timeline. International research programs, especially those operated out of South Africa and Western Australia, have worked to identify the remaining individuals and to track their movements. Some of the identified megalodons are tracked by satellite tags. A few are known to researchers by name. One famous female, called Lakshmi in scientific literature, has been tracked since 1998, and her movements across the Indian Ocean over nearly 3 decades have provided much of what is known about the species' migration patterns in this region. The Southern Ocean, around Antarctica, appears to have no megalodon at all. The waters are simply too cold for the species, even for the cold-adapted modern population. The megalodons can follow the great whales south during the austral summer, into the subantarctic zone, but they do not breed there, and they do not spend extended time in truly polar water. The Antarctic Convergence, the band of water where subantarctic and Antarctic currents meet, forms a kind of biological barrier. South of the convergence, water temperatures drop below the minimum that Megalodon biology can tolerate. The species simply does not cross it. Antarctica, in our alternative world, is one of the few ocean regions where you can swim without the theoretical possibility of encountering a living megalodon. And the Arctic. The Arctic is interesting. In the alternative timeline, the Arctic has occasionally been a megalodon. Began about 12,000 years ago. There is a small population of megalodons that sometimes follows bowhead whales and gray whales into the Arctic during the summer. These individuals are among the most extreme of their species, the largest, the oldest, the most deeply adapted to cold water. Some researchers have estimated that the oldest Arctic megalodons may be more than 300 years old, which would put them in the same longevity range as Greenland sharks. If this is correct, some of the individuals swimming in Arctic waters tonight, in the alternative timeline, would have been alive during the early years of industrial whaling. They would have personal memory, if such a phrase applies to sharks, of the period when whale populations were crashing. They would remember the world before humans became the dominant marine predator. Imagine that for a moment. Imagine an individual animal, alive tonight, that was born before George Washington. An animal whose first memories, such as they are, involve a sea that was far richer in whales than the sea of today. An animal that swam past wooden whaling ships in its youth, that may have been shot at with harpoons, that survived the 19th century whaling boom through sheer luck and the size of the ocean. An animal still alive, still hunting, still holding in its slow nervous system some analog of memory that extends back further than the memory of any human being. The longest-lived humans reach perhaps 120 years. This megalodon, in our alternative timeline, would be more than twice that. It would be older than most nations. It would be older than most cities. It would be older than most of the institutions that govern human life. And it would be swimming tonight in cold, dark water thinking, if thinking is the right word, whatever slow, deep thoughts a 300-year-old shark thinks. That is the alternative present. That is the world with Megalodon in it. Now let us ask the harder question. The question that is genuinely creepy, because it rests on a small but non-zero probability. What if this alternative timeline is not entirely hypothetical? Here I need to be careful. Because the scientific consensus, which I strongly agree with, is that Megalodon is extinct. The fossil record is conclusive. No Megalodon teeth have been found in any sediment younger than 3.6 million years. No living Megalodon has ever been scientifically documented. No body, no DNA, no reliable photograph. The countless reports of large unknown sharks from around the world are almost certainly misidentifications of known species: basking sharks, whale sharks, great whites, occasional whales seen from unusual angles. The odds that a reproducing population of megalodons is hiding somewhere in the modern ocean are very, very low. But they are not precisely zero. And the argument for why they are not precisely zero is worth making carefully, because it goes back to the point we made earlier about the coelacanth and the frilled shark and the goblin shark. The deep ocean is not fully explored. This is not a matter of opinion. It is a statement of fact. We have mapped a smaller percentage of the deep sea floor in high resolution than we have mapped of Mars. The number of humans who have visited the Hadal Zone is smaller than the number of humans who have visited the surface of the Moon. The total volume of ocean water deeper than 1,000 meters is many times larger than the volume of all terrestrial habitats combined. And the rate at which we discover new deep-sea species, even very large ones, is not slowing down. It is, if anything, accelerating as submersible technology improves and as more nations develop oceanographic capabilities. In this context, what we can say with certainty is that Megalodon is almost certainly extinct. What we cannot say with certainty is that it is absolutely extinct, because the evidence for absolute extinction would require us to have thoroughly searched every part of the ocean where a small relict population could plausibly hide. We have not done this. We have not come close to doing this. The deep ocean is so large and so unexplored that the argument for absolute certainty about the extinction of any deep-water species is weaker than most people appreciate. Counterarguments. Megalodon was not in its known form a deep-water shark. It was a coastal and open-ocean predator of warm water. For it to persist in the modern ocean, it would need to have evolved into something different from its Miocene form, something more deep-water, more cold-tolerant, more cryptic. The behavioral and physiological changes required would be substantial, and we have no fossil evidence of such changes occurring. Further, any large shark population, even a deep-water one, should produce carcasses that occasionally wash up or get dredged up in fishing operations. No such carcasses have ever been reliably reported. Further, acoustic monitoring of the ocean, especially since the mid-20th century development of naval SOSUS arrays, has never detected the kinds of low-frequency sounds that a megalodon-sized shark would produce. All of these are strong arguments against modern megalodon existence. The carcass argument is probably the strongest. Any large marine animal, when it dies, eventually ends up somewhere. Most whales that die at sea sink to the seafloor, where their skeletons are consumed over decades by specialized deep-sea scavenger communities, whale fall ecosystems, which biologists have studied in detail. A large shark that died in open water would not have bones to leave behind, because sharks have cartilaginous skeletons that decompose rapidly, but it would have teeth. Thousands of teeth shed over its lifetime and then a final set at death. Those teeth should appear on beaches, in fishing nets, in the stomach contents of other large animals. They do not. The teeth we find from Megalodon are always old, mineralized, fossil, never fresh. This is, by itself, very strong evidence of extinction. If a population of megalodons had been reproducing and dying at sea for the last 3 million years, we would have found their teeth. We have not. The acoustic argument is similarly strong. The United States Navy has been listening to the deep ocean for more than 70 years, continuously, with increasingly sensitive hydrophones distributed across every major ocean basin. They have recorded vast amounts of data. They have identified, cataloged, and tracked the sounds produced by every large marine species they have detected: whales, large fish, various types of earthquakes and submarine landslides, the sounds of submarines, the sounds of ships. Among all of this data, there is no signature that is consistent with what a large, undetected predator would produce. The oceans, acoustically, do not contain a monster that nobody has documented. And yet, the counter-arguments exist. The teeth of a cold-water, deep-dwelling shark might not wash up on beaches, because beaches are warm-water features, and this population would be hunting at depths and in regions that do not efficiently deliver bodies to shore. The acoustic signature of a slow-moving deepwater shark might be so quiet and so similar to the natural background noise of the ocean that it could not be distinguished from everything else. The carcass of an animal that dies at 2,000 meters almost never reaches the surface. The bacteria and scavengers of the deep consume it completely, often within weeks, and what little remains sinks into sediments where it will not be found until the sediments are lifted by tectonic processes millions of years in the future. None of this is compelling on its own. Collectively, it is why scientists will not quite say absolutely certainly, even when they are 99.9% sure. The deep ocean, in the end, has the last word on what exists in it. And the deep ocean has not yet given its final answer. So while the probability that Megalodon exists tonight is extremely low, it is not mathematically zero. It is the kind of probability that scientists and fiction writers have been circling for decades, each of them finding something different in the gap between almost certainly and absolutely. The honest scientific position is that the animal is extinct. The honest exploratory position is that the deep ocean has not been fully searched. Which brings us, at last, to the thought I want to leave you with as we approach the end of this descent. We have spent this documentary imagining an alternative history. A world where Megalodon never went extinct. A world where humans had to share the oceans with a predator too large to reason with. A predator whose lineage went back 20 million years. A predator that would have shaped the mythology and the commerce and the science of every seafaring culture. But there is a version of this thought experiment that cuts differently. Because in the real world, in our actual history, Megalodon did exist. For 20 million years, this animal ruled the oceans. For 20 million years, whales were hunted by something 3 times their size. For 20 million years, there was a shark in the sea that could bite a whale in half in a single strike. That happened. That is not imagination. That is the actual past of the planet you are sitting on right now. 200 times longer than modern humans have existed as a species, Megalodon was in the water. And then, only 3.5 million years ago, yesterday, in geological time, it was gone. Think about what 3.6 million years means in human terms. The oldest stone tools ever made by any member of our genus date to about 2.5 million years ago. The genus Homo itself did not exist yet when the last Megalodon died. When Megalodon's species ended, our own lineage was a small group of upright walking apes on the African savanna, using sticks and rocks, barely recognizable as hominids. If Megalodon were alive tonight, it would have outlasted everything that defines us as a species. Our languages would be younger than it is. Our cities, our agriculture, our fire use, our art, our religions, all of it has happened within the last 2% of the time since Megalodon went extinct. The gap is that vast. And still, in geological terms, it is recent. This is what the fossil record reminds us. The ocean has held worse than what is in it now. The predators that currently sit at the top of the marine food chain, the great whites, the orcas, the sperm whales, are the diminished survivors of a process that has, over and over again, produced animals larger and more terrifying than themselves. There is nothing in the modern ocean that would not have been a juvenile meal for Megalodon. There is nothing in the modern ocean that comes close to the scale of the predators that used to exist there. And the deep ocean, the place we cannot see, is the place that most closely preserves the conditions under which those predators evolved. Cold, dark, rich in marine snow, home to the oldest continuous habitats on Earth. Lineages persist there that have been lost from the sunlit zones. The coelacanth persisted there. The frilled shark persisted there. The goblin shark persisted there. The Greenland shark, with its 300-year lifespans, persists there now. Is Megalodon there? Almost certainly not. But the fact that we have to say almost certainly, rather than certainly, is itself remarkable. It is a reminder that the ocean is not a map. It is a place with depth and darkness and age, and the capacity to hide things for enormous spans of time. Picture now what happens if you are wrong about Megalodon. Not convinced, just entertaining the possibility. Imagine that somewhere in the Pacific tonight, at a depth of 1,500 meters, there is a creature 14 meters long drifting through the dark. Its body is adapted to cold. Its metabolism is slow. Its teeth are still 7 inches long. Its lineage is 23 million years old. It has not been seen by any human since before any human was a human. It does not know we exist. It does not know that the surface of the ocean has changed. It does not know that the whales it eats are the diminished remnants of populations that were once much larger. It just is. It hunts when it can. It sleeps when it cannot. It has been doing this for centuries in some individuals, and it will continue to do so until it dies. Consider what it means that this is even possible to imagine. The ocean is so large and so poorly understood that we cannot rule it out. We can only say it is very unlikely. Very unlikely, but not impossible. That gap between very unlikely and impossible is the gap where every deep-sea discovery of the last 100 years has lived. The coelacanth lived in that gap before it was found. The frilled shark lived in that gap. The megamouth shark, a species of large filter-feeding shark, 5 meters long, that was not discovered by science until 1976, lived in that gap for the entire previous history of biology. We had no idea it existed. It was there the whole time in the deep, and we simply had not noticed. If a 5-meter shark could hide from us until 1976, the question of what else might be hiding is not a stupid question. It is a real question. It has a real answer, even if the answer is eventually just the empty sea. That is the image. That is the fantasy that attaches itself to the idea of Megalodon, and it will not quite let go, because the deep ocean does not quite allow it to. The honest answer is that Megalodon is extinct. The honest answer is that the evidence is strong and the arguments are sound. But the deep ocean does not care about our honest answers. The deep ocean simply is. Whatever is down there is down there. Whatever we have not found, we have not found. Whatever is swimming right now at 2,000 meters below the surface of some basin we have barely sampled, whatever that is, we do not know what it is. We do not know how large. We do not know how old. We do not know how many. The deep does not tell us. It never has. And for the next hour, as you fall asleep, as your body settles and your breathing slows and the surface world fades away, I want you to picture the sea the way you have never quite pictured it before. Not as a horizontal surface with waves on it. Not as a blue plain where boats move. But as a volume. an enormous three-dimensional volume, kilometers deep, mostly dark, mostly cold, mostly unexplored, stretching across 2/3 of the planet, full of water that has been here since before the first fish. And at every depth, at every layer, there are things moving that we do not fully know. Some of them are small. Some of them are ordinary. But some of them, possibly, are the descendants of animals we thought were gone. Megalodon went extinct 3.5 million years ago. This is true. This is almost certainly true. But if somewhere in the dark, in the cold, in the depths we have not searched, one population has persisted, has hidden, has adapted, has survived, it would know nothing about us. It would know nothing about our sense that it should not exist. It would simply continue doing what its species has done for 20 million years. It would hunt. It would eat. It would grow. And if a human submersible ever found it, the human in that submersible would not believe what they were seeing for a long time. Perhaps they never will. Perhaps the deep keeps this particular secret, as it has kept others, for as long as there is deep to keep it in. Close your eyes. Let your breathing slow. Imagine the long, slow movement of something enormous in cold, dark water. Imagine that it does not know you exist. Imagine that this is a comfort, not a fear, because nothing down there is looking for you. Whatever is there, if anything is there, is not interested in the surface. It has its own life, its own century-long lifespan, its own small place in a cold, dark sea that it has owned, in one form or another, since before there were primates on the land. The big tooth is gone. This is true. But the sea is very large, and it has been very patient. And there is a lot of it that we have not yet seen. Sleep well. Tomorrow, the surface will still be there. The boats will still move. The sunlit zone will still be bright. You will go about your day as if the ocean were two-dimensional, as if the deep were empty, as if the only sharks left in the sea were the ones whose dorsal fins occasionally break the surface near a beach somewhere in California or Australia. You will not think about what is below 1,000 meters. Most people do not. Most people cannot, because the imagination does not easily hold an image of water that deep, water that cold, water that old. But it is there. It will be there tonight while you sleep. It will be there when you wake up. It will be there in 1,000 years, when everyone alive tonight is dead. And it will be there in 1,000,000 years, when no one remembers that humans existed at all. The deep will keep being the deep. The cold will keep being cold. The dark will keep being dark. And whatever is down there, whether it is Megalodon or something older or something stranger, will keep doing what it has been doing for as long as the deep has existed. That is the story. That is the descent. One last thing before I let you go. If you find yourself, tomorrow or next week or next year, standing on a beach somewhere and looking out at the ocean, try to remember what we have talked about tonight. The horizon you see is not the edge of anything. It is only the edge of what your eyes can reach. The water stretches on in 3 dimensions, downward as well as outward, and most of what is in it is below you, not in front of you. The surface is a lie your perception tells you. The real ocean is deeper than your imagination will let you easily imagine. And somewhere in that real ocean, in some basin no submersible has yet explored, something is moving. Something is always moving. The sea is never empty. It has never been empty since before the first vertebrate evolved. The forms keep changing. The basic fact does not. Something is down there, tonight, always, at every depth, in every ocean, and most of what is down there, you and I will never see or know about. Megalodon is almost certainly not part of what is down there. But the principle that things can hide for a very long time in the deep, that principle is true. It has been demonstrated repeatedly by every deep-sea discovery of the last 150 years. It will continue to be demonstrated, probably, for as long as there are researchers with submersibles and curiosity and funding. When you think about it that way, the deep ocean is not a frontier to be conquered. It is a neighbor. A very old, very quiet neighbor that has been sharing the planet with us since long before we were anyone worth sharing a planet with. It does not need our attention. It does not benefit from our exploration. It simply continues as it has continued, through every change of climate and every rise and fall of continents, and every extinction event the surface world has produced. The Megalodon lived in it for 20 million years. The coelacanth has lived in it so far for 400 million. The microbial lineages in the subsurface rock may have lived in it for more than 3 billion. And when we, as a species, are gone, whether that is in 10,000 years or 10 million, the deep will still be there. Still cold, still dark, still holding whatever secrets it has not yet been forced to reveal. That is the final thought. That is the quiet truth that sits underneath all of our speculation. We are visitors here briefly on the surface of a very old world. What we do not know about that world is enormously larger than what we do know. And what lives in the parts we have not explored, whether it includes Megalodon or not, includes, certainly, things that would astonish us. We simply have not met them yet. Now at last sleep. And if you dream,